When we talk about friction, this is what comes in our minds. Friction opposes motion. It consumes energy. It wear and tear out our machines, appliances, or our shoes and slippers. So we want to get rid of friction. Isn't it? Not a good idea. Believe me, it is not at all a good idea. Do you know why people slip on a icy road? Why it is difficult to climb on a polished steel pole? Why people fall down in their bathrooms? This happens when you don't have sufficient friction between contacting surfaces, surface 1 and surface 2. Imagine if there is no friction at all. Do you think you can walk on the ground, hold and lift any object, drive a bike, or write on a blackboard? No, you cannot do any of these. So friction plays a very important role in our day-to-day life. It is not a fundamental force like gravity. Instead, at the microscopic level, scientists believe it is the result of electromagnetic attraction between charged particles in two contacting surfaces. Now, to understand friction, let's consider block A, which is resting on block B. Because of weight of block A, it exerts normal force NBA on block B in downward direction. Block B exerts equal and opposite normal force NAB, normal force on A because of B in upward direction. Both of these normal forces are Newton's third law, action-reaction pair. Let's consider a force F is applied on block A. But because of this force, block don't move and remain at rest. As per Newton's second law of motion, if there is a net force F on an object, it must move with acceleration A, which is given by A equal to F by m. Here m is the mass of the object. But in this case, since block remains at rest, it means there is an equal and opposite force on block A, which is balancing this force F and keeping the block at rest. Friction always opposes the relative or intended relative motion. Because of force F, block A intend to move in the force direction. So block B apply a friction force opposite to A's intended motion with respect to B. This friction known as static friction. Static friction is a self-adjusting variable force. Its value changes as the applied force changes and always equal and opposite to the applied force till it reaches to a limiting value, where any further increase in applied force results in the start of block motion. If we observe the behavior of friction between two surfaces and draw a graph between applied force and friction between surfaces, we get a graph similar to somewhat shown here. Till peak point A on the graph, friction force is always equal to applied force F. Any point in between O and A on the graph corresponds to static friction and its value equal to applied force. So for any value of applied force in between O and A, friction is static and it is always equal and opposite to applied force. A is the peak point in graph and gives the maximum value of friction force between given contacting surfaces. This is known as limiting friction. Limiting friction is the maximum opposing force that comes into play when an object is just on the verge of moving over the surface of other object. This limiting value depends on normal force N and coefficient of static friction mu static. Value of mu static fixed for a given pair of material surface and is equal to the limiting friction divided by normal force. Or you can rewrite the same for limiting friction FL. When we increase the applied force slightly beyond limiting friction, the actual motion starts. It means the applied force now is greater than the force of limiting friction. The force of friction, the kinetic friction, during motion no more the same as limiting friction. Kinetic friction or dynamic friction is the opposing force that comes into play when one object is actually moving over the surface of another. In other words, when there is a relative motion between two objects or surfaces. Now the question is, if kinetic friction is equal to limiting friction. In reality, once motion starts and crosses the limiting barrier, friction between surfaces reduces somewhat. This reduced friction is known as kinetic friction and its value is given by Fk equal to mu k multiplied by n, where Fk is kinetic friction force on the object. Mu k is a coefficient of kinetic friction for the pair of contacting surfaces and n is the normal force. Kinetic friction is similar to limiting friction and has a definite value for a pair of material surfaces and depends on mu and normal force between surfaces. The coefficient of kinetic friction is always less than the coefficient of static friction, mu s. And we can say that the kinetic friction is always less than the limiting friction between two surfaces. The friction, it may be static or kinetic, between two surfaces depends on material in contact, the roughness of the surface, and the normal force between surfaces. First two factors decide the value of mu for a pair of any two surfaces of same material or different materials. Higher the atomic or molecule attraction between the contacting surfaces, higher the value of mu. An increase in roughness also contributes the higher value of mu. Another factor is normal force between surfaces, the force by which surfaces are pressed against each other. Combining these factors gives the value of friction between two surfaces. So we saw that the friction between two sliding surfaces depends on the material, roughness, and normal force between surfaces. But what about the area of contacting surfaces? Do you think if the area of contact increases, the friction force will also increase? Or in other words, is friction between two contacting surfaces dependent on their area of contact? Surprisingly, the answer to this is no. It is independent of surface area of contact. Since pressure equals force divided by the area of contact, an increase in friction generating area is exactly offset by the reduction in pressure if we keep the normal force constant. The resulting friction force depends only on the coefficient of friction of material and the normal force between two surfaces. At the end, in summary, there are three types of sliding friction forces. The first one is static friction, which is always equal to the applied force and in opposite direction. So static friction value is a variable, depends on the applied force. The second is a limiting friction. Its value is given by the coefficient of static friction multiplied by the normal force. And this value is constant for a specific pair of surfaces. Next one is kinetic friction, which is equal to the coefficient of kinetic friction multiplied by normal force, and its value again a constant for a specific pair of contacting surfaces. And you must remember that the static friction is always less than or equal to the limiting friction, and the kinetic friction is always less than the limiting friction for any pair of material surfaces. Now it is a time for testing your knowledge. Here are questions for you. Question 1. Block A is at rest on block B. What is the value of friction between these blocks? Question 2. If we apply a force F on block A in rightward horizontal direction and still block don't move, then what is the value of friction force on block A and its direction? The coefficient of static friction is mu s. Put your answers and comments in comment box. I hope you would have enjoyed this session. If you think you have learned something new today, then please click like button and subscribe us for similar type of videos. Thank you for watching. See you next time. Bye.